Good morning. So, taking a second detour from MicroCraft to learn a little bit about dynamic tile generation using this article Joe wrote on how to make a snake game. So, we're just going to step through this entire article and see what we can learn. But it looks like the entire snake game has two pictures, two tiles for the snake. I think it's two. One, two, okay, three. Head, body, and tail. And then has some helper functions to build up a tile set. Between that and the recoloring problem, that is what I'm currently facing, trying to get the level renderer for MicroCraft rewritten. So let's start stepping through this. Yeah, the snake game. Basically, the first time I played this was on QBasic and MS-DOS. You have a snake that you move it around the arrow keys, it eats fruit, and keeps growing longer and longer until it fills the entire screen. So, what do we have here? Basic problem, how do you draw a segmented snake? I don't know if we'll implement this entire game right here or just see if we can get an idea of how to get the rendering to work, which is the primary problem I'm facing. Also, I have not yet tried the Fat Bits program. That one was added to the Mini Micro relatively recently, I think. Yes, I would love to create a new image. What should I call this one? I'll just follow the tutorial. Image width, 32 by 32 in size. Sure. Why is it asking me to select a file? I thought I just selected a file. Interesting. Let's start from the top. New image. Okay, so that worked. I'm not sure what the problem was that first time. Alright, so let's try just doing exactly what it describes. Why the 4 pixel margin? Okay. Okay, trying to figure out how to explain this. So it's a 32 by 32 pixel, or 32 by 32 tile with a 4 pixel margin. But the cell size, so the tile display cell size is 32, the overlap is 8, which accounts for the 4 pixels on either side. Which apparently helps. You know, I have not experimented a lot with the tile display overlap feature, so the trick breaks up the obvious square grid of the tile display, makes it look fancier than it really is. You know, let's do it. I'm going to do exactly what it describes. Use the circle and fill tool to make a round body with 4 pixel empty margin all the way around. Okay. Tool size 1, drawing a circle, 4 pixel margin. Easy enough. Of course, that's not the right spot. circles by pixel is a little bit weird. For example, having trouble getting to start the circle right there. I need to go up a little bit more. Oh, where's the undo? There is no undo. There is an eraser. It's funny, no matter how far up I go, it still wants that circle to have 5 pixels at the top. Oh, how do we delete that? Select, delete, cool. You know, another way you can get to pick the circle exactly where you want. We need a Control-Z function in this thing. I keep mashing the Control-Z trying to undo what I just did. Alright, so there's our circle, 4 pixel margin. Which of these is, there's the paint bucket. In the MicroCraft game, every tile, like every icon in the tile set, is composed of 4 shades of gray, equally spaced over the spectrum you can see in the bottom left corner. And that is basically what I'm going to be trying to duplicate here. Black background. Alright, so is that saved? Is it automatic? Does it save as we go? Let's go back to the article. You know, if we look at our VS Code project, and it's not there yet. The question mark for help, S. So you press S for save. Good to know. Pressing S, we're now saved. There it is, cool. Now we need a head and a tail. And I'm going to cheat just a little bit. I don't want to mess with drawing that circle all over again. And can I copy? I want to copy. You know, I'm not seeing a copy button. Okay, so what happened here, in most paint programs, you hit Control C to start a copy operation. But in the Mini Micro, Control C is to break a program, which is what I just did. So, once more. We're drawing the head now. I'm going to call that good enough. Yeah, Control Z would be really useful here. Okay, 4-color head. S for save. It's really bothering me that I can't get a 4-pixel gap at the top with this thing. Like, I can get it at the top or the bottom, but not both. Okay. Drawing a tail. Save that. Okay, we got a head. We have a tail. We have a body. Decent program. It needs a little bit more work. I don't know, it might just be me. I might just need more practice. Okay. Is it Q for quit? Yes. So, what kind of display? Could use draw image draw each pair of the snake on the screen, fill rect to clear it. Or sprite display, create sprite for each segment of the snake. Or for the tile display, create a prepared tile set with all the snake parts in rotation. Draw and erase by simply setting cells in the display to the appropriate tile index. Traditionally, like the old school snake games were basically tile displays, setting characters on the screen. And yeah, in this demo, tile display is being used because it makes collision detection easier. But here's the important thing, making a tile set at runtime. Yeah, tile set. It's basically what we have up here. Bunch of little pictures, all all stitched together into one big picture. And then a tile display is able to pluck out individual bits by index, reading left to right, top to bottom. Let's see, and there's a tile util that I have never used before. Methods to assist with a tile set. So what we have in here, 2 images. Split a tile set up into a list of separate images. Okay. To tile set, combining a list of images into a single tile set. That's really useful. Save images, save a whole list of images to disk, load images. Save a tile map to a file. Okay, could be useful. Load from file. Oh yeah, and there is a level editor built into MiniMicro if you want to do some simple tile map editing. Okay. And what we have here, load rotated. Rotate by an angle. So we take in the image path and what angle we want it to be. Because, gotta run that. Interesting. Okay. So we have our head there if we just view it. Or another way you could do this, file, load image. I think this will work. Yeah. If you want to load the image explicitly, or with this helper function, it's rotated by 30 degrees. That has no visible difference. But that does, okay. Flip it 180, that works. About 70 degrees. Does it only do 90-degree increments? 270 works. Yeah, it looks like it only does 90-degree increments. So that's good to know. Is that intentional? Image, rotate. Oh yeah, it was like right there, 90-degree increments only. And then we have a make tile set. And does all that, returns a tile set. Let's try that. If we run this, we'll have access to the make tile set function, which creates just an empty tile. I guess that's to fill the screen. create an images array composed of 13 empty tiles. And then load, okay, so this is just help initialize the array. And then load the head, body, and tail in all the different orientations into the image array and generate a tile set. So let's view that. Do view, make a tile set, no such image tail.png. Did I not save the tail? I didn't save the tail. Oh, that's obnoxious. Okay. Oh, what was the path to that program? This won't take long. Getting good at it now. And then we press S to save, because it does not know to warn you to save your unsaved changes. Q to quit. There, we have our tail. Now, do view, make tile set, tile utils unknown because I did not import it. Do I need to rerun it? Okay, so that's neat. That is the tile set it generated. Took all those different orientations, shoved them into a single image that is fit to be loaded into a tile set. I'm suspicious that this one has a black border and these do not. I'm not sure what the consequences of that will be. Still, that is interesting. I'm going to try one more thing here. Going back to our MicroCraft game, we have a palette we've been working with. Modify this just a little bit. So what this does, it basically dumps our MicroCraft palette into the global namespace. And then I need the color object. Really, I just need this get function. And then let's make a recolor function. image interface correctly. Pixel will get the color, set pixel will set the color. P equals image dot pixel x dot x and y, and then that should give us a one-dimensional array with no, it's not one-dimensional array. It's going to give us HTML color. Here, it's like load image, head.png, pixel 1010. There, you get your HTML color. And then you need to do color dot to list to convert that into your one-dimensional array of RGB, red, green, blue, and alpha values. So let's do this. And then we basically need let's view that image again. So each of these tiles is composed of 4 colors, split evenly on the range of 0 to 255 on the grayscale. So what we do is we grab any one of the red, green, or blue components, divide it by 4, and then floor that value to get an integer. It's going to be 0, 1, 2, or 3. And then that will tell us which of our 4 colors to use for recoloring it. And what that means, let's call this alpha, P0, divided by 4, floor that, and then let's do it like this. Instead of passing in 4 individual colors, we're going to pass in a colors array indexed by that alpha value. Now, how do I want to represent this? Assign the image is an object. I should just be able to edit it in place, but let's go ahead and return it anyway. Recolor image, and then we're going to feed it a set of colors. And the way this system works with this palette, you feed it 3 digits. Each one has to be between 0 and 5. 5 being, like, the 3 numbers are the red, green, and blue components, and 0 through 5 is like how bright that component is. And it needs 4 colors because these are 4 color images. The first one is the background, which we are going to make blue. So red, green, blue. Next is the color we were using for the eyes. Let's make those red. 500. And then the background, kind of go for a brown color. 530, red, all on red, partial on green, off on blue, and then the outline. Let's make the outline green. And then we get to see if this whole system actually works. List index 63 out of range on line 57. Oh, right, dividing by a value on the range of 0 to 55 divided by 4 will give you a range of 0 to 63. So we actually need to divide by 64. And I'm seeing nothing. Like, impressively nothing. Oh, right, what'd I miss? Let's ignore the palette thing for now. We'll use the built-in colors, which should work just as well for this case. There you go. It did do the recoloring. Dumped it all into the tile set. The benefit here is I can use the tile set to draw to the screen instead of the per pixel thing I've been doing. And oh, I see why it didn't work. Because get is returning a palette index, which we then need to shove back into the colors array to get the actual color, I think. Unknown in this context because we did not actually run the getColors function. But now we do. And there you go. It is recolored. We are taking a series of 4 color black and white images, recoloring them with our palette, and creating a tile set, which is really cool. Plus and minus to zoom. And I'm going to be taking systems something like this and shoving it back into the MicroCraft level renderer, hopefully on the next video. So, hope you can join me then. See you later.